Okay, well it's 10:42:40, and that cap has drifted down to about 10 volts. Which is it's pretty interesting. It took a long time to wander down. Let's go ahead and discharge that baby the rest of the way. So I'm not sure what that cap, what the thinking was there. This doesn't appear to be a repair, or I don't know what's going on. Well, I'm going to go ahead and just remove that, unless somebody was trying to, you know, that input voltage, ripple voltage on that first stage is a little high. Not bad though. I think I'm just going to go ahead and unsolder this and see what we can find here. And somebody just tacked this on the top of this other cap's lug here, so I'm just gonna. Yeah, that didn't even. What the heck? Weird. Some funny stuff going on in there. I took that cap off, and that terminal is real blobby. And what's interesting is underneath all that was another piece of wire. That's an actual little baby piece of wire, so I don't know what's... Let's see here. These meter readings are tough to see sometimes. Maybe I'll light up them. Make sure that if you go measuring these caps, especially if they've been in circuit, I'm going to just shorten the leads together here. Make sure they're damn good and dead, because if you hook your meter up to it, it might not respond too well. That's weird. I've seen this a lot. I don't know what to make of this. This cap has got, this is a 30 microfarad cap and it says 37. I'll take this down and hook it up to my big cap meter. I've got a Syncor cap meter. This spaghetti, if you can hear that cracking, it's just stiff as a damn board. So this is probably how this thing came right out of the factory, and it's just got these huge leads. It's kind of a bad repair. Look how long those are. That's not very good. Well, I'll tell you what we're going to do. I'm going to test these. Real quick here. Let's see what the ripple is on that power supply. And we'll see what's going to happen here. Let's see that. It's about 2 volts, almost 3. And it's 2/10 on that side. I have no idea why that cap is in there. Okay, well, let's see here. So this has got 107 on one cap, 125 on the other, enough to give you a little thrill there. And you can see if you turn the radio off, that cap discharges pretty quick. Now, okay, I'm going to test this other cap and report the findings back. Well, I tested this. It says it's 37 microfarad, which is weird. And it has about 100 microamps of leakage. And there's the seal. So, well, I'm just going to pull that out of the circuit. There's no sense having extra parts in there that don't do any good. Well, I don't know. Appears to be in okay shape. So I'm not sure what to think about this. Let me do a couple tests here just for fun. Here's a good way to damage your voltmeter. I'm going to measure the resistance of a couple of these resistors, but that cap still has about a volt in there. Today's modern digital voltmeters are pretty good about not getting blown up or having some protection on them. But older voltmeters, maybe not so much, so you might want to make sure these things are really discharged. Yeah, that could take a while. Now, what do we got here? Check on this side of this cap, see what it's doing. Well, it looks pretty dead. And it's trying to rebound. Naughty, naughty. Okay. And we can maybe do that. Well, I'm going to check the resistance of a couple of these resistors just for fun. One is 2 ohms, basically 2.2. This one's supposed to be K. And just for fun. Yeah, it's actually 1200, which is probably a tolerable situation. And on this side, this is 2 ohms. That's interesting. So that says 22 ohms. I swore that said 2 ohms. Okay, maybe it doesn't. It might be 22. It's a bad thing about those drawings. They're a little shaky sometimes. You can't figure out what's going on. So those 2 caps are okay. Or 2 resistors, I'm sorry. Here's these always make me laugh. That's the AA automatic volume control resistor. They're usually a pretty big value. And that's in the megohms. Testing resistors in circuit can sometimes be a little tough. If you test them in circuit and they seem reasonably close, then I'd say yeah. If you're really being pretty fussy, you'll need to at least lift one lead. Sometimes that can be a pain. Although I've been known to clip one lead and then tack it back together. Not a great idea, but it does work. See, that says that's supposed to be 22 megohms. It's slowly walking up. It's 1.6 megohms, so it's off a reasonable amount. Now, sometimes on the drawings they say, you know, the resistance. Yeah, here it says 20%. Well, what's 20% of 2 million? What is that? I'm trying to think what 10% of a million is. A couple thousand. My math skills aren't up to par today. So that resistor looks like it's drifted off quite a bit. It didn't appear to affect the operation of the set. Let me pull that ground lead loose, just to make sure. Oh, I don't know. Don't think it's going to hurt anything. No, if I've got a 2.2 meg ohm resistor. I was trying to think what that is. Actually, that resistor is in tolerance. Okay. Well, what to do? I think I'm gonna hook that replacement noise cap back up for now. And what do I do with my, dang it. It'll stick away. I don't like bending the leads at right angles, just raw right angles. I usually form them around a little small rod. Gives them a nice look, I think, but that's me. Okay. Now, so the radio back up. Now this radio is kind of interesting because it isn't using the chassis as a ground. It actually has a ground in it. Now there is a cap that connects the negative, or what they, the common or ground, if you want to call it that, to the chassis for RF purposes. Now one thing I've noticed about those types of grounding systems is sometimes they can get a little bit of soft buzz in them. And if you flip the cord over, they go away.
You're listening to ABC News. Are you paying too much for term life insurance? There's a tremendous price war among the major term life companies. Rates have dropped dramatically in the past few years. For example, a man age 45 non-tobacco user, $1 million of coverage, $75 per month level rate for the next 10 years. Or a man age 50 non-tobacco can obtain $500,000 of coverage for a monthly premium of only $110 per month, guaranteed not to change for the next 20 years. That's right. Level rate guaranteed not to change for the next 20 years. If you're a smoker, we have great rates available for you as well. At Turnbusters, we specialize.
Well, I'm going to let you go here. We'll talk to you later.